Excellent. Hello, everybody. We are going to be talking about multiplying exponents in this video. There are 4 different rules that we are going to cover today. So the first one is called the product rule, right? And this is what's going to happen when we are multiplying 2 of our bases that are the same. Remember this x, that's our base. Whatever's being raised to the power, that's our base. So if we have the same base and we're multiplying them together, we're going to add the exponents, right? So we're multiplying x to the m and x to the n. So we just add m plus n. All right, so let's go ahead and actually look at some real examples. So first thing you want to check, yes, these are the same base, okay? We can rewrite this as x to the 3 plus this, 3 plus 6. 3 plus 6 gives us 9, so we can rewrite that as x to the 9th, all right? Our next example, both of these have a base of y, okay? So it's kind of actually 2 ways that you can go about this. For the sake of the product rule, we're going to use that one, right? So we have the same base, we add them together. -2 plus 3 gives us y to the first, right? Was just a normal, plain old y, okay? The other way you could have done it, you could have noticed the negative exponent, brought that down, and then used the quotient rule that we talked about last class. Once you get into further examples, harder examples, you can kind of pick which way you want to go about it. But for this one, product rule, if you have the same base, you add the exponents, all right? The next one, we're actually going to talk about these 2 simultaneously. All right, so we have the power rule, which is when we have a term raised to a power raised to another power. All right, so we have this power to a power, okay? And what we're going to do, since we have basically m to the a, what we're going to do with these exponents, we multiply these 2 exponents, that m and that a, all right? If we happen to have multiple terms inside of our parentheses, this is what we're calling the power of a product rule, okay? Because this is a product, right? Raising it to a power, all right? You are just going to distribute it to both and use the power rule that we just discussed. So you distribute that a and have x to the m times a. Bring that a to the n as well. So you have y to the n times a. All right, so let's go ahead and do some examples with this one. We have a product being raised to the 2. So what we're going to do, you're going to distribute it. We're going to have x to the 3 times 2, y, you know when you don't see it, it's really a 1. So y to the 1 times 2. The biggest thing that I see students do, and I was guilty of this when I first learned this, I would always write that as x times 3 squared. No. That would give us, if we had 3 squared, that would give us x to the 9th. That is not the same thing, okay? We're not doing 3 squared. We're bringing it in, we're distributing it, we're multiplying. 3 times 2. That's going to give us x to the 6. Y to the 1 times 2 is just y to the 2nd. All right? The biggest thing, make sure you are careful of distributing that exponent in. You're not actually using it like a normal exponent. You're using it like you're distributing it. All right? Another one. This time, we have so many things to distribute it to. All right? And when we have an actual whole number, this is where we use it for its intended purpose, all right? That's when we really do what we do. If we have a variable to a power, again, we're just going to multiply our 2 exponents. But when we have just a plain old number, another way of thinking of it, this could be like 2 to the 1. So if we did 2 to the 1 times 4, that's how we get 2 to the 4th. All right? But again, you do not have to write that once. You can just leave that as 2 to the 4th. All right, 2 to the 4th is going to give us 16. X to the 4 times 4 gives us x to the 16th. I clearly learned 16 when I came up with this example. Y to the 3 times 4 gives us y to the 12th. All right, that is how that one will simplify. All right, the last one that we're going to talk about is the power of a fraction. All right, this is where we have a fraction being raised to an exponent. Same idea as before. You distribute it to both pieces, all right, or however many pieces you're going to have in there. And again, we are multiplying our exponents together. All right, so in this example, we are going to throw it back to our last video talking about our division rule. So I would want to simplify the inside first, then we can go ahead and apply that outside fraction, that outside power. All right, so remember, when we have the same base, we're going to subtract. So x to the 2 minus 3 gives us x to the negative 1. That negative exponent tells us x to the 1 is going to be in the bottom, right? So when we simplify that, we have y to the 5th over x times z to the 4th, and we cannot forget that big parenthesis and exponent, all right? Now it's time to distribute. We're going to distribute the 3 to every single term in here. And we're going to end up with y to the 5 times 3, x to the 3rd, z to the 4 times 3. And now at this point, it is just straightforward multiplication. 5 times 3 gives us 15. There's nothing to multiply that 3 by there. For our z, 4 times 3 is 12. And that's it. All right. Final example, all right? We're changing it up. We're making things a little more difficult. Again, first step, I want to clean up the inside if we have to, all right? So again, we're going to have y to the 5 minus 2. That gives us y to the 3rd. Since it's positive, that y to the 3rd term stays up top. All right, so this gives us x squared, y to the 3rd. On the bottom, we're left with z to the 3rd. Now we have this negative 2 on the outside. So the way you can do it, this is the way I would recommend, since it's negative and everything is being raised to that negative power, you are going to flip absolutely everything. All right, so you'd flip it. You'd have z cubed up top, x squared, y cubed on the bottom. And remember, once you flip it, you get a positive exponent, okay? Then we can do exactly what we've done, right? Z, we're going to shortcut it. 3 times 2 gives us 6. For x, 2 times 2 gives us 4. For y, 3 times 2 gives us 6. And that is it, all right? The other way you could have done it, if you wanted, you could have distributed from this point, but then you're multiplying by a bunch of negatives, and then that just gets kind of gross and messy. So that is why I personally would recommend just flipping the entire thing and then using your positive exponent. Okay, but both will work. It's going to be whatever you prefer.